And welcome. In this video we'll be talking about permutations. So a permutation is an ordered arrangement of items that occurs when, and there are two things we need to consider here. Firstly, no item is used more than once. And secondly, the order of arrangement makes a difference. And so I'll say more about this, the second part here, as we work through them as these examples to explain what these mean. So let's say that we have 5 singers and they are to perform on a weekend night. How many different ways are there to schedule their appearances? So the way I like to think about this is that we have 5 spots to fill in our lineup. So somebody's going to go first, somebody will go second, third, fourth, and fifth. And so those are the positions we've had to fill. Now, if everybody's going to perform exactly one time, as far as who would go first, we would have 5 choices there because there are 5 singers. But after we pick our first place performer, we'll only have 4 to choose from when it comes to picking the second place performer. And then this would be 3, 2, and 1. So in order to figure out the number of different ways, we would have 5 options in the first, 4 in the second, 3 in the third, 2 in the fourth, and 1 in the fifth. And I need to find the product of each of these. It's 5 times 4 times 3 times 2. There would be 120 different lineups that are possible just using these 5 singers. All right, and when I say that the order matters, so in each of these 120 scenarios, I'm using the same 5 singers. But when I say that order matters, to me it's a different lineup if a person sings first or if they sing last. And so even though I'm going to be using the same 5 people, so the group of performers isn't going to change, but the lineup changes. So when I put singer number 1 in the first position as opposed to the last position, those are distinct lineups to me. So that's where I mean that the order of the arrangement makes a difference. In how many ways can a police department arrange 8 suspects in a police lineup if each lineup contains all 8 people? So in this case, we have 8 positions to fill. 1, 2, 3, 4, 5, 6, 7, 8. And for our options for the first position, there are 8. But once we choose somebody for the first position, they would not be available for the second position. So there would just be 7 people from which to choose. And then each case, we have 1 less person to choose from. So by the time we come to this last position, it's determined who would be there. But so we have 8 times 7 times 6. So clear 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And believe it or not, there are 40,320 possibilities there. So in each of these examples, I had a certain number of spots to fill, and I had exactly that number of, in each of these cases, it was people to fill those spots. That doesn't necessarily have to be. So let's look at another example. It says a DJ can play 7 songs, but there are 13 to select from. So he only has time to play 7, but he has 13 he or she can choose from. In how many ways can the program of this segment be arranged? So in this case, we've got 7 spots, 2, 3, 4, 5, 6, 7. And as long as we're not going to repeat any songs, so we want to make sure we play 7 distinct songs. As far as the first song that we play, we would have 13 choices. But after that, our choices diminish from 13 up to 12, and then to 11, to 10, to 9, to 8, and then we'd have 7 songs to choose from here. So even though we had 13 to choose from, we weren't going to play all 13. So we just had 7 slots. So this is 13 times 12 times 11 times 10 times 9 times 8 times 7. So, geez Louise, there are 8,648,640. And let's look at another example. A club has 10 members and is to choose officers, president, vice president, and then a secretary treasurer. If each office is to be held by one person and nobody can hold more than one office, in how many ways can those offices be filled? So for president, vice president, and treasurer, secretary, let's see. There are 10 members of the club, so there would be 10 options for president, but then only 9 for vice president and 8 for treasury secretary. So this would be, well, 9 times 8 is 72 times 10, so that would be 720. So there is a little bit of a shortcut for calculating permutations. It involves a formula with factorials. So the formula for permutations of n things taken r at a time. So n is the pool from which you're choosing, but r is the actual number of things that you're going to choose. So, for example, in that last example, I had 10 to choose from, but I was only going to choose 3. So the n would be 10 and r would be 3. So the way that we calculate this, first of all, let's look at the notation. We use a capital P for permutations and subscripts for n and r. The n precedes the p, the r follows, and to calculate this, we use a factorial. So when we have n factorial, that's the same thing as n times n minus 1 times n minus 2, all the way down to 1. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. Which is 120. If we have 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's the product of that number and all of the smaller whole numbers down to 1. Now, in this formula, we have a quotient of factorials. So in the numerator, it's just n factorial. And in the denominator, it's n minus r factorial. So let me just show you a few examples, and then I'll relate this back to some of the earlier problems where we were counting permutations. So when I have 7p3, that's 7 factorial over 7 minus 3, which is 4 factorial. So this would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. Now notice, a lot of these can be canceled out. And I'm really just going to be left with 7 times 6 times 5. So 7 times 6 times 5. Oh, okay, 7 times 6 times 5, which is 210. So this is 210. For 10p4, I have 10 factorial over 10 minus 4, which is 6 factorial. I'm going to show you a little shortcut here. 10 times 9 times 8 times 7 times. Now, this would be 6 times 5 times 4 times 3 times 2 times 1, but that is just 6 factorial. And that's going to make this a lot easier. I know that these two expressions have mean the exact same thing, 6 times 5 times 4 times 3 times 2 times 1. Since they have all the same factors, all of those are going to cancel out. And so I'm just left with 10 times 9 times 8 times 7. 10 times 9 times 8 times 7, which is 5,040. 6 p6, so this would be 6 factorial over 6 minus 6 is 0. And so that's a special case. 0 factorial is defined as 1. So in this case, this is 6 times 5 times 4 times 3 times 2 times 1, all over 1. So it really just comes down to 6 factorial. 6 times 5 times 4 times 3 times 2 times 1, and that's 720. All right, so how does this relate back to some of the things we discussed earlier? So in this situation where I had a club has 10 members and it's going to choose 3 officers, that's 10p3. So this is 10 factorial over 10 minus 3, which is 7 factorial. So that is 10 times 9 times 8 times 7 factorial, all over 7 factorial. But those factors are all going to cancel, and we will have 10 times 9 times 8. So it was the same result that we get here. We could also use that in any of these preceding examples. So where we have 13 songs to choose from, but we're just going to play 7. So that's 13 P7. This would be 13 factorial over 13 minus 7, which is 6 factorial. And that would simplify down to this product here. All right, so I hope that helps with permutations. I'll see you next time.